Well, the quality of the videos I made earlier weren't what I thought they should be. Too much noise and the resolution wasn't very good, so I'll try to improve that. Um, so what I'm doing here is showing you how to do something that some of you may need to do. If you have an island, you probably do not. Like if you have Chincoteague or um, Tangier Island, Smith Island, you won't have this problem. But um, areas where there's a river inlet, or in this case the James River over here, this is a solution to a problem that's hard to fix. And it comes from this. If you have trimmed a DEM, as I have, to my field area, which is Jamestown, Virginia, I still have this area, this black border. You can see it around the edges, and it actually goes inside an inlet right here, this inlet right in here. And the problem with that is that when you calculate your flooded land, here you are, when you calculate your flooded land for the first time, you really can't tell how much of the island has been flooded by that 1 foot increase in sea level, even when you reclassify it. Yeah, you can see the area that's not flooded. You can see the road that goes around the island. But over here on the margin, you really can't tell what's been flooded. And without being able to do that, you can't really communicate effectively with the map. So what you want to do is go ahead and export it to the polygon, which you've already, so you started with your 1 foot raster calculation. Let me get that back. You started out with your 1 foot sea level rise calculation where you had values of 0 where it was unflooded and a value of 1 for flooded, and then you reclassified that one so that you would end up with just one value of just the flooded land, and the other part's called no data, and the no data zone is where you now see the island again. Okay, and then after you did that, you exported it as a polygon, a shapefile. And the reason for that is you don't want to publish a raster. They're too big, and it also has some other disadvantages. Okay, one of them is that when you convert it to a polygon, you notice it smooths the perimeter a bit, and it does that. How well it does that depends on the resolution of your digital elevation model, but in this case it still looks better than the blocky raster. Okay, but what are we going to do about this orange that's filling where we don't want it? And the way we're going to fix that is by adding from the 2016 data, ArcGIS 2016 data, we're going to add a hydro layer, and that we're going to add the detailed water layer. Right click, add to the current map. Okay, and so here we go. You'll notice there's some white lines in here because this detailed water layer includes rivers, streams, and also wetlands and marshes. What we want is just the actual rivers and streams, not areas that are partially wetted, or they're not necessarily open water. So so what we're going to do is we're going to do a selection by attributes, and you notice also that the red that you see peeking out here, that's the area that got flooded by 1 foot of increased sea level. So you can see how this is going to improve the result. Detailed water, we're not going to remove it from a selection. We're just going to create a new selection and add a clause. And we're going to set this F type is equal to streams and rivers. Then add it and then run it. So it has selected the streams and the rivers. And I'm going to right click on the detailed water layer and go to data, export those features. And since this is my Okay, this, yep, and the input feature, the input feature is the detailed water, but I got to give a name to this output, and I'm just going to call it JT Rivers because Jamestown Rivers makes sense. Okay, and its purpose is very short. It only is necessary to do a clip here or to erase some feature. So I'm going to run this. And so now it keeps the same color green, but if you turn off the other part, you'll notice that the wetlands part is gone. So I'm going to remove this detailed waters, and I'm going to change this to some other color. Actually, it doesn't matter. I'll just leave it this way. Okay, so now what we're going to do is erase. We're just covering up right now what's underneath, but we want to really remove this. We want to remove this area. So how do we do that? We're going to go to Analysis and click on the red tools. We're going to click Erase. Erase Analysis. Your input feature that you want to erase is the 1-foot poly. This is the the vector file, the shape file. So we're going to put in the 1-foot poly. Now you may have called yours something else, but it's your 1-foot sea level rise flooded layer. So erase these features. The erase feature is going to be the Jamestown Rivers. And I'm going to call this, when I'm all done with it, the output is going to be called Jamestown, JT, sea level rise 1-foot TRM. Okay. And let's see if it works. All right, it's completed successfully. So now let's see if it really worked. You see it created this new one. Let's turn off the green, turn off this old red one, and there you go. It's now just the part that got flooded by an increase in sea level of 1 foot. Okay, so you would repeat this process for your 2-foot and your 3-foot flooded areas, your flooded polygons, and this way they'll be much more clear as to what was actually flooded by the rise of sea level.